So, good evening. This is not the normal salutation you've been getting. Um, I'm doing this presentation about almost 10:23 East African time. So, this is just in furtherance of our discussion on the idea about mud whispering. You know, I've made, I think, a short video presentation on the matter. If you remember, I told you about how um, my interest in mud initially came up through my exposure um, on compressed earthquake technology, which is now called compressed stabilized earthquake technology in Nigeria. For some reason, like I pointed out, somehow compressed earthquake technology did not seem to get to the place where um, the people behind that vision um, wanted. And so I believe I believe strongly um, that in some quarters it got to a point that it was just agreed that um, the introduction, the experimentation, and the project was a success. And seemingly nobody wants to go back to um, asking questions about why uh, the state of compressor big technology in Nigeria is where it is at. Incidentally, today I was discussing with I think a fellow architect about this same issue. Why um, it seems to have just stopped. Nothing has moved on. I'm not going through that right now. I have um, an interview I did with architect Kolawole. Um, I'll put it up. I'll put it up in due time. I won't give too much into it. But today I just want to talk about um, why compressor big technology seem to have failed in Nigeria. I use that word um, not unsparingly. Okay. So in this presentation, we look at why or the role of denial and its role in the failure of compressed stabilized or compressor big technology in Nigeria. Like I said, um, I don't think it's a very popular stance. I don't think it's a very popular stance. So, but compressor big technology but it's still a promising solution to the housing crisis in Nigeria. We see it catering to the needs for affordable, sustainable, and locally sourced building materials. However, despite this potential, the widespread use of compressed big technology has faced significant hurdles leading to its failure in several contexts. Among the various factors contributing to the setback is denial. This denial is both at individual levels and systemic levels, which play a very pivotal role. To understand compressed big technology, it is important to know, for those who know already, basically locally available soil, specific type of soil, not just any soil, mixed with stabilizers or not, and then compressed to form durable bricks. Now, these bricks have been have been proven to be very friendly environmentally. They've been proven to be cost effective. Well, that is another issue. That is another issue. I recall how I used to argue with a friend of mine. He's an economist. When we argue, I come up with this. My stance is it is cost effective in the long run. I think people got the wrong impression over time that if you spend 10 million to build a simple project, if you say compressor big technology is cost effective, you spend like 3.5 or 5 million because it's cost effective. No, we'll look at those issues along the way. But then also it's suitable for our climatic condition in West Africa and Nigeria in particular. But its entirety, it's that is the main selling point. The environmental friendliness, the cost effectiveness, and then the suitability for the climatic conditions. So, this is just by the way. Um, if you observe the cover art, the pictures or the images on the presentation, it's an instance of badly done bricks somewhere. I'm not going to mention where. Probably maybe in the next one or two presentations down the line. But this was in 2025. It was done in 2025. So you can have an idea how bad this situation is, where bricks of this nature could be produced anywhere in Nigeria. So continue to listen. Nigeria is a country where we all know that housing deficits are very prevalent. And so compressed earth brick technology offers a very innovative way to addressing this issue by promoting sustainability and reducing reliance on imported materials. Those are you could also I mean you could almost hear the cliche in this. So let's in examining the role of failure of compressed urban technology in Nigeria, we need to look at the critical resistance to change. Critical resistance to change. I always like to cite this example of Hassan Fati. For those who don't know, Hassan Fati is called the architect of the poor. He was Egyptian, and his works were basically in mud architecture, Adobe, basically. And so I like to cite this example mostly to my students. The new Gona debacle, the new Gona experience, whatever you may call it. In many communities, we know that there's a strong attachment to traditional materials and methods. So the new Gona was conceived and touted as an intervention to improve the lives of the villagers in the old village of Old Gona. It was a fantastic concept. And so the designs were drawn up and executed using traditional building materials, construction methods, which Hassan Fati oversaw. The project was finished, and what was left? Hey, villagers, move over to your new accommodations. The people refused. Now, um, there could be many explanations to this, but the takeaway I had, and the takeaway I always like to give to my students as their takeaway, was that the people were not consulted. In fact, I read one of the articles I read about it. Said the people refused to move. They refused to relocate. Why? They were not consulted. So New Ghana ended up being a luxurious go-to location for tourists and almost a ghost village. So the integration of compressed big technology requires a very deliberate paradigm shift in mindset. And this is often met with that resistance I talked about. So denial is one of the benefits of this new technology. Denial of the benefits can stem from a lack of trust or unfamiliarity with the process. In Nigeria, some of the experiences and anecdotes have not been very pleasant. From inexperienced artisans claiming knowledge about the production of the bricks to untrained masons doubling as unqualified bricklayers with disastrous and painful financial results. Let me explain. Once again, I give the example of what I teach and how I teach my students. There's a difference between a bricklayer and a mason. mason, masonry, blocks, stone. Okay, then you have the bricklayer. Now, bricklaying is a very, very precise artisanship. While you may have um, a bricklayer seamlessly transiting and be able to work with any of the other masonry materials, block, adobe, stone, it's very difficult for a stonemason, a mason that's um, experienced with adobe or sanctuary blocks, to work with bricks. It takes a lot of patience and a lot of expertise. Well, in Nigeria, many builders and homeowners um, tend to ignore or downplay the advantages that compressed brick technology offers. They prefer to stick to conventional methods, which they perceive are more reliable because of the trauma, when you go through with somebody who's unqualified and messes up your work in using bricks. So if the one selling point of compressed electric technology or any other earthing technology sustainability, not enough sensitization has been done, especially in academia or training institutions, to recruit more believers, in quote, albeit practitioners into the field. Almost all conceptual ideas produced by students and approved by their mentors seem to be on conventional materials and building practices. For CSB technology or for compressed electric technology to be successful, proper training and education on its use, benefits, and maintenance are essential. However, denial manifests in the form of neglecting these educational needs, as stakeholders may believe that the existing knowledge is sufficient. This can and lead to poorly constructed buildings, inadequate understanding of stabilization processes, and ultimately structural failures that could have been avoided with proper training. I want to go back to the compressed earth-based technology in Nigeria. Unfortunately, very very unfortunately, a center that was set up, the Center for Earth Construction Technology. In the past, I remember when I was a student, I would steal time and then go, study the books. I was so fascinated about it, and since I finished school, started practicing, eventually went back into academia. I've had time and reason to go back there. And what I saw, what I've seen, or what is there, it's heartbreaking. It's heartbreaking. We'll look at that in another um, presentation. So another consideration in this denial process is the underestimation of local conditions. The effectiveness of compressed orbit technology, it varies according to soil types, climate condition, and construction practices. Denial often leads to underestimation of these local factors, with stakeholders assuming that compressed earthquake technology can be implemented uniformly across different regions without adaptation. For example, a simple soil test for suitability can be conducted to assess and confirm if the soil can be used without remediation or otherwise in one location, but may require advanced soil analysis and laboratory testing in another location. So this oversight can result in failures due to incompatibility with local environmental conditions, leading to a lack of confidence in the technology, which has happened. In the Nigerian case, what could happen if the government decided to adopt compressed earthquake technology as a policy and order the implementation for all capital projects? What would happen? What could happen? I am I would say that with all sense of sincerity. Overnight, the story of compressed earthquake technology would change. Overnight. This is a fact. Despite the proven efficacy of CSB or compressed earthquake technology, denial at the level of policymakers can and has hindered its integration into national housing strategies. Government entities have denied the necessity for supporting innovative building solutions, prioritizing conventional construction methods instead. In Nigeria, you have what we call the cement mafia. I remember, from years ago when cement was just, almost, it was, let's say, two or three times less what it costs. What you buy one bag of cement now today is what you get almost three or four bags of cement. Let's say about 15, 20 years back. It's a sad situation. In Nigeria, this is a fact, like I said. Um, but these are things that can be helped, but it will take a lot of time. So this lack of institutional backing seems to have stifled local initiatives and discouraged private sector investment, further exacerbating the technology's failure. Hence, the lack of government support and policy integration is one of the key factors in the failure of compressed earthquake technology in Nigeria. Another case of back to the example of a new Goran experiment again is ignoring community needs and inputs. The success of any technological solution depends on the buy-in from the communities it aims to serve. When community voices are denied or ignored, such as through inadequate stakeholder engagement, there's often a disconnect between what the technology offers and the actual needs of the people. The denial of local input can result in poor adoption rates, sorry, and failure to tailor solutions that effectively address specific challenges by communities. Finally, denial operates as a significant barrier to the success of compressed urban technology in Nigeria. To overcome this challenge, stakeholders must acknowledge its existence and actively promote awareness, education, and engagement. By fostering this mindset, or a mindset that embraces change, values local knowledge, and encourages government support, compressed urban technology can fulfill its potential as a sustainable and effective solution to Nigeria's housing crisis. Addressing denial not only is crucial, not only for the advancement of compressed urban technology, but also for the broader goal of sustainable development in the nation. This is one of the presentations or one of the focuses that we'll be looking at as we explore this theme, as we continue this discussion on um, the role of the mud whisperer. So I'm going to sign off here and see you on another presentation slash podcast. Good night.